2.3 Motion in One Dimension by yours truly. For problem number 25, we're asked that if a car has an acceleration of, I believe it is 7.2 meters per second squared, how long will it take for it to go from 0 to 60 miles per hour? Okay, so from 60 miles per hour, we need to start assessing some things. First of all, we need to convert that to meters per second. Alright, and so in problem number 24, we did that. We took 60 miles per hour and converted it to 26.82 meters per second. That's the final velocity. Well, if we convert 0 miles per hour, that would be an initial velocity of 0 meters per second, and then we're given the acceleration of 7.2 meters per second squared. So the question asks us is how long would it take? In other words, we need to find time. So we have an acceleration, two velocities, and we're asked to find time. Next step in the process is to find an equation that will help us use the initial velocity of 0 meters per second, the final velocity of 26.82 meters per second, with the acceleration of 7.2 meters per second squared, and find time. So if we look on page 57 in our textbooks, we find that one of the equations that has all of those variables is actually the v equals v naught plus a times t. So the first step would be to find an equation. This is the equation. Notice that it has all the variables that I have listed to the right hand side. So now I just plug in the numbers. And for time's sake, you don't necessarily need to plug in the units. Mr. Adams does because he likes to, but you don't necessarily have to. But when I go to solve this equation, essentially I'm going to end up with 26.82, and I'm going to divide both sides by 7.2, and I'll get a number, and then you'll see that the seconds, the meters cancel and one of the seconds cancel, so I'll get a number in seconds, and that should equal my time. So 26.82 divided by 7.2 is 3.275 seconds. And that's how long it would take. So if I'm in a car and I want to go from 0 to 26.82 meters per second with the acceleration of 7.2 meters, it would take me 3.275 seconds to do that. Okay. Now, sometimes students get caught up on these dimensional analysis. How do we know the answer is left in seconds? Well, if I write this out as a fraction, what we're essentially doing is dividing a fraction by a fraction. Whenever you divide a fraction by a fraction, you multiply by the reciprocal. And what this will do is it'll flip our seconds squared up to the top and our meters to the bottom. When you cancel out the meters with meters and one of the seconds with two of the seconds on top, you're left with 3.25 seconds, and that's the time that we have. So again, car starts from rest, goes up to 26.82 meters per second with a constant acceleration of 7.2 meters per second squared. How long would that take? Plug it into the formula, and we get 3.275 seconds for our time. And that's pretty much it.